Hi everyone, thanks for joining. Um, my name's Ash McKenzie. For those who I haven't met before, thanks for joining. Appreciate it. I'm here today to talk about Pure SSH support for LFS via GitLab Shell, which is a bit of a mouthful. There's a few technologies mentioned there. Hopefully, after a bit of a discussion and a bit of a dive here, we can understand a little more about what each of those mean. I've prepared some content in a GitLab issue as opposed to a slide deck, and structured in such a way that there are sections. So I'll go through each section and pause and see if there's any questions. Hopefully take about 35 minutes. There is a Google Doc attached to um, this meeting. It doesn't have much other than a link to the slides, or at least the content. So yeah, if you have any questions, feel free to pop them in the chat or ask them on the issue. I'll share the issue in the Zoom chat now, and I'll share my screen and we'll get started. So just doing a bit of adjusting here. So we'll start with the basics of LFS. What is LFS? There's a definition listed there. It's Git large file storage. LFS for short replaces large files such as audio samples, video, and graphics with text pointers inside Git while storing the file contents on a remote server like GitHub, GitHub Enterprise, or GitLab. Now, that quote is taken from the Git LFS project page. And yeah, it's a project. The Git LFS project, I believe, was started by GitHub team members. It's definitely maintained by GitHub team members, and came out approximately, the first version was in June 2014, from what I can determine from their tags and releases. And yeah, why would you use LFS when you have non-plain text content you wish to version control, such as the aforementioned content types there? So if you've ever accidentally committed something into a Git repository, like an image or a sensitive piece of data, you know that information stays within that project or that repository for, essentially forever, unless you take action to extract it out. So LFS is an attempt to support the concept of version control for non-plain text file types. It's a completely separate project to Git. It's a separate binary, and it's written in Golang, not C. And yeah, like I mentioned earlier, it's I believe quite a few years. Git's been around quite a few years longer. So Git LFS came out in 2014. We, GitLab, have supported LFS since about 2016. It was very tricky to determine exact dates, but I found a blog post referencing how to configure and how to use LFS around 2016. We've had support for quite a number of years, and not much has really changed in terms of the specification or features in LFS. It's largely remained the same up until about version 3.0. And prior to this version, prior to version 3, only HTTPS was supported, and that is regardless of what kind of Git remote you were talking to, be it HTTP or SSH. Under the hood, all LFS operations were conducted over HTTP or HTTPS. But version 3 onwards introduced support for what is called Pure SSH. But technically, it was broken until version 3.5.1. And that's an interesting kind of period there. I'm not sure how long in terms of time between version 3.0 and 3.5, but I think it was merged into the support was merged into version 3.0. But as far as I know, we are still the only source control provider that has implemented support for Pure SSH. So I think because nobody had implemented support, it wasn't discovered until quite late that key features did not function correctly. And we added support into GitLab Shell, which is the project that handles SSH connections, incoming SSH connections. We added support into GitLab Shell for the Pure SSH protocol in 17.2. And just for the specifics of this presentation are on the Pure SSH, but in doing so, I think it's important to show the flow and the bit of history of prior to the Pure SSH support. So here's a graph of, or mermaid diagram, I should say, of Git LFS using HTTP, the heavy Git client here. And this diagram, whilst referring to HTTP, is probably more specific to the scenario where you're performing a Git clone or a Git fetch or a pull over SSH, because the diagram here is referring to GitLab Shell, which is, again, the project that handles SSH connections. So you can see the initial request is handled by GitLab Shell, responded back with the Git data, and there's a little bit of glossing over here, some of the details, but essentially Git LFS, the command line tool, which is wired up via Git hooks, which we'll talk about a bit later, goes through the list of LFS objects that it needs to pull down, and from the Git client, so your laptop or wherever you're executing the Git command, that would then perform the HTTP get effectively of the LFS objects and be serviced by a workhorse directly back to the client. So this is key to why the why behind why Pure SSH is a good idea, or at least why there was a need for it and why it's something we implemented, because of this essentially this last line, or this last direction here, where the client is receiving the LFS objects via HTTP from GitLab effectively. Some additional links there around the homepage and a tutorial, but I'm presuming most people have at least tried Git LFS, or at least aware of its, I guess, the basics of operation. So I won't go too much into that side of things, but there's some links there. I'll just pause briefly just to see if there's any questions. Feel free to ask them directly or in Zoom chat, or fire them in the GitLab issue. Checking. Cool. So we'll dive into LFS a little deeper here. And so a lot of the information around Git LFS is on the GitHub project page. So the gitlfs.com website is essentially a deployed static version that comes from this project here, the Git LFS project. And so Git LFS, I'm just going to read the quote because it's pretty good. It's quite sort of, it's not too long. It's quite accurate. Git LFS stores a pointer in the Git repo in lieu of the real large file. So this is the difference between committing a real object into the Git repository versus the concept of LFS. So the pointer is swapped out for the real file at checkout using smudge and clean. And these are different filters. The smudge and clean filters are part of the core of Git and are designed to allow changing a file on checkout, which is the smudge filter, and on commit, and via clean, the clean filter. Git LFS uses these techniques to replace the pointer files with the actual large files that are in use. So it's a pretty good description. And I think the next part that really, the question that comes, I think, is how does the actual, in the flow of things, how does the smudge and clean filters kind of become effective, or the reality of things, how does that happen? It's via Git hooks. So when you set up a new repository to use Git LFS, or if you clone an existing repository that has LFS objects, there are 4 hooks that are updated post-checkout, post-commit, post-merge, and pre-push, and they have different Git LFS operations executed inside of those things. So we'll see a little bit of that later on when I do a demonstration. And setting git trace to 1 equals 1 and git LFS trace equal 1 before any sort of git operation that has LFS work to do, that's key. If there's no new LFS objects to pull down or to upload, you won't see much LFS output, but it will show you the LFS hooks in action. And there's quite a lot of output there. It can be hard sometimes to see some of the LFS operations, but they are prefixed, I believe, with git-lfs, so you can grep based on that, and I'll show that in action a little bit later on. And probably more relevant to the LFS overview section, but you can do other things like locking files, which is something that you can do via the command line, and that is also reflected in the UI, in the GitLab UI, so you can unlock and lock files and run git LFS locks to see what locks are in place. And that, I think, complements workflows around editing images and things like that, where it's a bit of a different workflow from your traditional, I guess, plain text, but that feature exists and does work the same way for HTTP and for Pure SSH. So there's some good additional links that I posted there. I feel like this is a really good article on how LFS works with a bit more detail. Some links to the LFS HTTP internals and the SSH internals. It was originally referred to as the SSH adapter, but the implementation, which we'll see in a little minute, is called Pure SSH. So that's the LFS deepest section. If there's any questions, I'll just pause there for a moment before moving on.
I believe that Sam has one, and I would like to ask another one.
Excellent, Sam.
I was asking, is the lock local or does that push up to the repo somehow?
Great question. It does push up, and I can demonstrate that. So that, yeah, the command is git LFS lock, and then the file name or the file path. And as part of doing that, it does actually communicate with the remote side of things. And in terms of the core of GitLab, it adds an LFS file lock model entry, and yeah, it's reflected on the UI with a little padlock. But great question.
And my question is, let's say you don't have enough storage to clone the LFS repository fully. Is it possible to maybe create a shallow clone or access LFS files on demand?
Ooh, the first part, these are great questions as well. So the order of things are, when you clone a project, it will pull down the entire Git repository data first, and then look to see through those files if there are any sort of special, I guess, LFS looking files that need to have objects downloaded. So what you would experience in that scenario is the Git repository will look complete. It'll have all the files on disk. But if the LFS sort of hooks aren't executed, or because you run out of space, let's say you might see a few files that are what you expect. They might be, in the case of like image files, they might look perfectly valid. And then where you run out of space, where the LFS hooks weren't able to complete, you would see the files just containing, I guess, like metadata. And I'll show that a bit in a sec, what the files actually look like on disk. So a bit of a weird situation, I suppose. You would see an error in the Git clone or fetch output, but yeah, I think it'd be not a great situation, be a little bit confusing. But I think you would know based on the errors. And yeah, if you were able to clear out some disk space and try again, I believe it would be able to cope with that and to continue. So it's a good question. Might actually test that one day.
I was actually thinking about the use case when you just don't have enough storage. Let's say your laptop has 500 gigabytes, but the repository is 1 terabyte with all the LFS files. And maybe there is a workaround so you can manually load some files but ignore the others. So that was the use case I was thinking about.
Yeah, it's a really good idea. I mean, Yeah, and we do see a lot of the issues we do see raised around LFS are around like timeouts and efficiency around cloning and basically interacting because yeah, they typically are significant in terms of their file size. Most people use object storage to locate, to store these items, but yeah, currently it's a kind of all or nothing type of scenario, but it's a real bolt-on kind of feature, or at least command line tool. It really does come in after the fact. Like it's really not that sort of well integrated into the Git, I guess, workflow. But yeah, I guess some sort of like I know, for example, I've heard Google have a virtual file system sort of support system that they have in place that can do some trickery around like accessing files and things like that, which would be pretty cool. But yeah, I'm not sure how you would facilitate that, at least on the command line level. When you access an LFS object in the GitLab UI, it is rendering that sort of fresh, I guess, depending on what it is. But if it's significant in size, yeah, I think it's a good question. I don't have a good answer, unfortunately, but I like that question.
So I've shared the tool that I use for basically my backup. It's called Git Annex. So that tool can partially download files. I think it's pretty similar to Git LFS in that regard, that you store files in a separate place, not in the Git repository itself. So I was just thinking maybe I can replace this tool with Git LFS, but it sounds like not really.
If Git Annex has more sort of configurable options and it sounds like it's a little more capable. But yeah, there are some alternatives out there. I won't dive into those today, but yeah, it's pretty good. There are, I think, some better alternatives. And I know that the Gitly team are working on something that sort of does this type of thing in the back end without any additional client tools, which would be awesome, which would be exciting to hear about in the future.
Thank you.
Thanks for the link. I'll update the issue a bit later with that. I'll have a read as well. So thank you. Pushing on, we'll go through now, I guess, into the most relevant section is the Pure SSH based LFS protocol. As I mentioned earlier, it arrived in 17.2. There's an epic here if you'd like to read up on that. It spanned multiple milestones. I can't actually remember off the top of my head where it began, but it's a community contribution from two community members, Kyle from Kitware and Joe Snyder. They're fantastic. Basically just shepherded the work through and clicked the merge button. So it was fantastic, really great experience, and just, I guess, another fantastic demonstration of the power of open source. And they've got a great new feature courtesy of the community, which was awesome. And under the cover, it leverages the, I guess, I think there's only two implementations of the SSH protocol support in, I think this is the only Go one. It's called Git LFS Transfer, and it's by this very awesome group called the Charm Group, the Charm Bracelet GitHub project. They've got a number of different really interesting projects. I highly recommend you look into they've got a great sort of art style and yeah, really cool. But this does all the heavy lifting. And so Git LFS transfer is the command that is sent to from the client to the server, and that's used as part of the negotiation between do I use HTTP or SSH, and we'll see a little bit about that later on. And so from the user perspective, there is no difference in the UX or the flow from talking to having the LFS perform operations over HTTP or SSH, and there's no client config changes necessary. In fact, you don't need to do anything. It's auto-negotiated, which is sort of a little challenging, as we'll see in a little bit. And it's perfect for environments that don't allow HTTP traffic. So this is the main driver for this feature. Is there are customers and scenarios where you know, clients are not able to talk to their GitLab instance over HTTP and only via SSH. And in that scenario, LFS is, prior to this implementation, was not possible. So this is a really enabling feature for some customers. And so we're really looking forward to hearing reports of how it's working or how it maybe not working or how we can improve. So at this stage, GitLab.com hasn't enabled this. I'm not sure we will, to be honest, as a default enabled. I'm not entirely sure. From a sort of performance perspective, some very rudimentary benchmarks didn't really show a significant improvement or degradation in performance. So I guess it's just one of those options we have, and it's been really interesting for some customers. So how do I know if my GitLab supports Pure SSH? So it's a little bit tricky. There's no simple kind of check. Maybe we should do something on the front end that and the UI that sort of makes it clear, because there is a configuration that I talk about a little later where you can enable supporting the GDK and Omnibus, but they're sort of tucked away back-end settings. There's currently no sort of UI indicator or setting, but perhaps that's something we could do in the future. But for HTTP, you run this command, and this is the key command here that is essentially HTTP support. So if you run this and you get some JSON back, I'll try and demonstrate this a little later. I'm trying to not flick between my terminal and the browser, but you'll get a JSON fragment returned, which contains a token that you can use for a period of time. I think it's 2 hours. And that if you get a JSON fragment response there, that tells you that HTTP support is enabled for LFS, which it almost always should be. That's the standard. The reverse here for SSH is the same command, but the same SSH command, but instead of git LFS authenticate, you run git LFS transfer. And if you read into the documents around the internals of the Pure SSH support, git LFS transfer is the command chosen to decide if this is going to be Pure SSH. So in this scenario here, for GitLab.com, this will return unsupported command or an unknown command, and that just speaks to the fact that it's disabled. So I think I talk about it a bit later on, but I'll mention it here. This is the SSH command. This is not the git command. So when you're running a git operation that has LFS kind of work to do, the git LFS command, if you have version 3.0 onwards, will try this command first. So even if you do not have it enabled on the back end, it will try and then fall back onto the traditional HTTP version. And there's no way to control this trying SSH support first. There's no config option, unfortunately. So it really is just one of those things. It tries and falls back. And so there is a situation if a customer has version prior to 3.5.1 of GitLFS and the support is enabled, they will have a bad experience because it is broken. I inquired on the GitLFS. Here we go. I mentioned it here. There's no way currently to set this as an option. I inquired on the issue board to see if it was possible to gauge the version of the client version inside the GitLab Shell. Can we see what client version of GitLFS is being used in the operation? But currently there's no way to determine other than, I think, just a very high level version. So definitely recommended to keep up to date with GitLFS command line tool. And when you're performing an actual Git operation, so here git push, the only way to tell in this context running git push if you're using, or if HTTP or SSH is responding, is to enable these two environment variables and grep for this output. It's that's the most definitive way I've found. You can grep for other things, but it will always try Git LFS transfer. So you will see mentions in the output of trying Pure SSH. And so this one here, if you see output, which I'll demonstrate in a little bit, then you know you're using HTTP. And if not, it's using SSH. And we have a similar diagram here. The only main difference between the SSH and the HTTP version is under the hood, GitLab Shell is performing the request. So this, I think item number 5 here, line number 5, and is requesting the LFS objects, via Workhorse on behalf of the client. So it is still happening. There is still an HTTP request occurring, but that is being conducted by Shell. It's originating from GitLab Shell and not by the client. And then once the objects, Shell has those objects, it passes them over to the client. I don't believe there's any sort of streaming going on here. I believe it's buffered on the shell itself, GitLab Shell instance. So I have to be careful there. If we did roll this out on .com, that this point here doesn't become, overwhelmed with storing large objects before they're passed on to the client. But lines 5 and 6 are the major differences between using SSH, the SSH protocol for LFS versus HTTP. And I just have some listed files here. I'll just open just one, but I think there's a few more files, but these are the main files. So in the context of GitLab Shell, this file here, command.go, there's a bunch of things that happen. The most interesting is the build function here. We are passed in the args that are passed in. The command type is the most interesting attribute here, which is essentially, in the context of Git LFS, will either be Git LFS authenticate or Git LFS transfer. These are considered the commands. There's a bit of an overlapping terminology here, but here we have a gigantic switch determining what's the requested command. So you can try a bunch of these. My personal favorite is the personal access token command. You can generate a personal access token via GitLab Shell, with various scopes and various, arbitrary sort of duration just via an SSH command. It's really cool. It's worth poking around. But the most interesting and relevant here are these two sections here. So this is LFS authenticate. That's the HTTP. So if Git LFS authenticate's being passed in, we return this command, an instance of, or a struct, I guess, of LFS authenticate command. And in the case of LFS transfer, which is the Git LFS transfer command, we return a very similar looking struct, but from the LFS transfer package. And here we have a configuration guard around. So this is what stops. This is the configuration option that is driven by the settings. There's a config.yaml, and this determines whether or not you want to enable Pure SSH support, which is disabled by default. So from here, you can launch into the various commands and see how they work. But this is probably the most relevant, I guess, for to start with, to determine the flow of the flow of the operation. And that's the file here. Just pause there briefly. Any questions? Cool. All right. Jump into a demonstration. So like I said earlier, the Pure SSH support, LFS support in GitLab Shell is disabled by default, but there is a one-liner. This one here, I've collapsed it just so I could, copy and paste a little easier. It's documented in the GDK LFS how to enable it. It's just setting this GitLab Shell LFS Pure SSH protocol enable to true, reconfiguring and restarting SSH. And if you wish to enable support for Omnibus, There's a link there to how to do that. So I'll switch over to sharing my terminal. Hopefully everyone can see my terminal.
Yep.
Cool. Cool. So I've got a clone here of LFS create files test, just hanging off the root account on my local GDK. And there is a number of text files in here. So just very, very briefly, the way Git knows and Git LFS knows, I suppose, more relevant, is how to, which files are LFS objects, which files should be LFS objects, handled by a file called .git attributes. And so this file is driven by, or updated, I suppose, you can say git LFS track, and you give either a blob or a specific file or specific files, and you say that I want this this pattern to be considered LFS. So everything in this file, everything in this project that is a text file is considered LFS. So if I pick the most recent one and see they are just timestamped files, I've got just a little one-liner that I use to create them, just so I can create them quickly. But as we can see, the contents is in fact a timestamp. But if we look at this file using TIG, which is the Git terminal TUI, terminal user interface, you can see if we jump down to the, as far as Git is concerned, contents of this file are not a timestamp. They are this right here, which is the LFS spec and the object ID and its size overall. So this is what Git knows about. And so to answer your question earlier, Dimitri, if the LFS download operation failed, this file here would have literally this contents and not the timestamp. So that might be fun to test if I have some time, but it's clean. I just updated earlier, and I believe my GDK has Pure SSH disabled. So if I watch, I can type. I do push with the trace enabled. You can see Git LFS. Yeah, they are prefixed. Git LFS. You can see the various HTTP queries that are occurring. We first verify that there's no locks. So there's no lock on the file, so there's no locks there. And if there was, it would bail out and then attempts to upload. So we get some information back here around where to post the file. Actually, that's the output, I should say. So here is the actual file now uploaded. We can see that I might poke around a bit and show you on disk where that is. Some tokens, and yeah, so this is where to put it. This is where it's actually posted, put, I should say, and that is now on the server, which I can't actually do both, show my browser and terminal, but that is, I'll show that in a sec. But that's using Git LFS over HTTP, the standard. I'm just going to go and copy the one-liner above, enable. And really, the reconfigure is just updating the GitLab Shell config YAML, the Pure SSH protocol to true, and restarting SSH. So if I do touch, and the same command with hoping for HTTP, there's nothing. I'll do another file and I'll show you what you see. So here we can see LFS attempting a Pure SSH connection. this will always occur, even if you don't have it enabled. If you have a Git LFS version 3.0 beyond, you'll always see this. And you'll see a spawning, in the case of the SSH support enabled, you'll see a spawning Pure SSH connection and all the different connections, sorry, the SSH commands that are happening here, which using the Git LFS transfer command, very similar flow, slightly more kind of slightly easier to follow. I think it's using upload and that's about it in terms of, yeah, so it's sort of a little bit opaque exactly what's happening. You don't see as much in terms of the specifics, but I find it a little easier to follow. I'll try the same with here on the output. We'll see HTTP requests. You'll still see, like I said, attempting pure SSH connection because it always tries. And did I set that to false? I did. It does attempt the SSH command, asking the git LFS transfer command, but it fails with unable to negotiate version. So that's the config, the guard that. So the GitLab Shell has essentially responded saying, I don't understand this command, and then falls back. It tries it again, and then doesn't actually say falling back, but it goes to using HTTP, and you can see HTTP commands we saw earlier. And whoops. And it's quite tricky to see the difference, but yeah, if you're grepping for HTTP, you'll see it. But that's, I guess, the flow of a Git push over HTTP and versus SSH for LFS. I'll just paste in some of these other commands that I got that I reference in the presentation. So here's where we try and just use SSH and say, do you support HTTP, LFS HTTP, and you get a response back, a JSON response. And because it's not enabled here, it's false. If I ask the same, but for transfer, we'll get an unknown command. But if I re-enable this, I think these are really handy to know, these SSH commands, to know to sort of poke at the server separate from the Git and Git LFS context. This has been really helpful in testing. So now it should be enabled. So we should still get a JSON fragment back for HTTP because we do support it. But like I said earlier, the Git LFS client will always try SSH first, so you can't really tell it to not. But we now get a very SSH looking response that's waiting for another response from us to show that it is in fact supported. So that was the demonstration on, I guess, the how you tell if you're using SSH or HTTP for LFS, some of the commands for SSH. There was one other thing I wanted to show. That's right, the Git LFS blocks. There's not at the moment. Locks, it is locked. And if I change my sharing, my GDK here. A little padlock down here. for the file that I just locked. And unfortunately, there's not a little icon or an annotation here, which would be nice because that would be consistent with the, I guess, list view. But you can see the only option here is to unlock. So you can sort of, I guess, by the fact that it is saying unlock, you can kind of imply that it's locked. But yeah, we also, I believe this is always here, and depending on the actual file type, whether it's an LFS object or a regular Git object, this still here, but if it's LFS, it'll do an LFS lock. If it's a regular file, you can lock a regular file, but it's sort of separate from LFS, but looks the same. If I scroll down to the bottom now, it is no longer there. And I would show you in the terminal, but it reflects the same Git LFS locks. Shows there's nothing there now. And just one final tip, I'm sure this isn't news to anyone, but this setting all of these environment variables to 1 is really handy. You get a lot of information, be prepared, pipe it somewhere, or use a TEE or something, because it's a lot, but it's super handy, and it really helped whilst shepherding the work through, because there were plenty of MRs that weren't quite right, and so seeing the various specifics under the hood was really helpful. But that's my presentation. I'll just pause it there for any questions. Thanks very much, everyone, for listening and hanging in there. But if there's any questions, fire away. If not, thank you.
Thank you. I have one general question. Where do we actually store the LFS blobs on the server?
Great question. So I'll quickly flick back to my terminal. So in the context of GDK, they are just on disk unless you configure object storage. And so that's the case for Omnibus. They are stored on disk. Now, in the GDK, they are under the GitLab project shared and then LFS objects. So this will be good. Open up that file again. So this is file. Let's have a look. Have a look at the contents. This file's got a timestamp. Let's see what Git knows about this file. Just that so I can see the full object ID. So if I go into GitLab shared LFS objects, we should see a 40 direct. No. 40. Yep, 40, which is the first part of the object ID. And then I believe the whole thing, there's another section, FF, which is this part of the object ID. And I believe there should be a full file, or is it? It's the next portion minus first 40 and FF. So this file, this is the real file here. So we should see a timestamp inside this file. Yep. So if you were to configure object storage, it would do wherever you wish to store it, but in a very similar format, I believe the same file structure. But yeah, it's inside the Git data. You have the OIDs and the size, and then the actual LFS objects are sort of pulled down after the fact. It'd be interesting actually to sort of meddle with the hooks to kind of pull it down, but fail the LFS. I've been doing a lot of experimenting lately. I'm trying to fix some challenges with mirroring, project or repository mirroring with LFS objects, trying to avoid a race condition that exists. I'm sure it probably springs to mind what that race condition might be. If you have very small Git repository data, but large sums of LFS objects, the Git data is updated before the LFS objects are synced. So you have a situation where you do a clone or a fetch. Git LFS says, hey, I need to pull down some objects. Oh, they haven't been synced yet. And it's, so there's some edge cases. I think we found a way around it. But that's why I've got a bunch of these commands already in my terminal, just because I've been experimenting with the order of things. But yeah, hope that answers the question.
Yeah, thank you. That's very helpful.
Awesome. Well, thank you both. Really appreciate you hanging out, and thanks for the great questions. I'll wrap it up, and yeah, thanks again, everyone.
Thanks for the presentation.
Thanks, Sammy. Thanks, Dimitri.
Thank you. Bye.
Take care.